Libraries, senior centers, schools, and community centers. In addition, all events in city facilities.
How's everybody doing? Let me get my glasses. So today, I'm going to go ahead and go over OSI layers in networking. Then we're going to go into cabling. And then ideally, we would have you make cable, but since we're doing online only, we will look at some of the ways to make cables. Okay. If you can please download your unit or week 2 notes and assignment. Hi. Okay, so we will find our week 2 located here. We have an assignment in class today, and then we're gonna talk about the lab, which is on practice lab. So it gives you a little bit more understanding on how to use network devices with OSI layers. And then the quiz is due by next Saturday. So don't forget to complete the assignments by next Saturday and the quiz. So I'll go over the questions while we're talking about the notes for OSI layers. And OSI is very important in networking. You have to understand that each of the layer has specific protocols, which is a set of agreement that we establish to enable certain services. So for example, when you visit your website, you type in HTTPS. That is a protocol, so it would submit requests to the web server, and the web server would respond, acknowledge, and serve you the website. So OSI was created by International Organization of Standardization. This is a way that we can standardize networking devices so that way it will work with many different types of systems and along with the services. So you can buy a different brand router, plug it in, and be able to have the same type of services across. So in the OSI, there are 7 layers, okay? And if you are pursuing networking, you would find that these 7 layers are essential for Network Plus. One second. Okay. So if you have questions, please unmute and ask. I will go through some of the concept, okay? So in the first layer is where you would have bits that's being sent from your network interface card and to the cable, or if you're using wireless from your Wi-Fi adapter to the air, right? We're submitting the bits, and this is how the physical layer is used. It's used just to convert everything to bits and then to be able to send that across the network. In the second layer, you have the data link layer, and this is important. This is how your data would be framed. So think of it like if you need to send a bicycle to your friend. And in the data link layer, this is when you would package each piece of the bicycle, each piece into a box. So what it does is it creates a way to track the pieces, so when the data gets to the destination system, it will be able to reassemble using the other layers. So this is a way that we can manage the data. As you know, the data, when we send it across the network, even 2 different networks, that's the internet, all your data is in pieces, okay? And it's a way that we can link the data together by using some kind of tracking mechanism. So what it does is it has the information about the destination and the source, and we rely on IP addresses to send it from one network to the other. Once it gets inside the network, the data link layer actually is in charge of pinpointing where that system is inside the network. So often you would see the switch being used here because the switch job is to identify the physical address of a certain system. So it's going to point to where that system is in the segment of the network. Now, the third layer is in charge of IP addressing, and it's in charge of routing. So this is mainly used from network to network, router to router, right? So you would use IP version 4 addresses or IP version 6 addresses to be able to forward it to the right network. And then the next layer is the transport layer. This is a way that we can send data from host to host, especially when we're looking at from one network to another. Now in the session layer, this allows you to have multiple sessions or multiple occurrences or communication in across the network. So for example, when you open up your browser and you open up 3 different websites and you log into these websites. So sessions layer, its job is to incorporate wrap the protocol to make sure that you are able to access 3 websites simultaneously with different channel of communications for different services. So often you would see simplex, half duplex, and fullplex. So simplex is unidirectional. It means that something can only receive or send one way, okay? It's like a one-way street. You can either go forward or you can go the opposite way. There's no mix. The half duplex is where we would have bidirectional. It's like a two-way street. We can have something send forward and receive, but it's not full, meaning that you're not going to have the maximum capability and performance. Then we have full duplex. It's like how we would have 4 lanes going one direction and 4 lanes going the other direction on a freeway, where you can send and receive simultaneously at full performance. So in that sense, what you have is some system would only receive or send. Some system would receive and send, and some system would receive and send simultaneously. Okay, so layer 5, its job is to establish different type of session for different type of services that's required by the system. Then the next few layers, the next 2 layers is the presentation and the application. From the user standpoint, presentation and application is what we see. For example, you visit YouTube and you click on a video. So at that point, it actually, you're using all layers in the OSI. First, we need to send, right, our request to YouTube with the bits. So it's going to go through your system, which is layer 1 from your network interface card. Then it gets to, you know, the wire, then your cable connects to the router or your Wi-Fi modem. Then that modem, right, take the data frame from layer 2, use the IP addresses, right, the public IP address for YouTube, and sends it. Then the transport layer and the session layer establish the communication for that request. Then when YouTube respond and give you the video, your system is using the session, the presentation layer, to translate the video data, right? And it's reassemble that data in one piece, making sure that it's intact, then it's going to present it onto the browser, which is the application layer. So the application layer is a way that we can interface with specific services through a program. So when you visit a website, you're actually using all the layers in the OSI. Okay? So let's answer some questions. So at the first layer, layer 1, which is for question 1, it says, which OSI layer sends and receives bits? And that's your physical layer. That's a way that we can submit a request in 0 and 1s from our system to the rest of the devices on the network, like your Wi-Fi modem or your router at home. And then from there, it's going to move on to the next one. Okay. In layer 3, this is when your router is routing your requests to the other networks. That's what we call the internet. So device IP addressing is accomplished at the OSI layer 3, which is network. Okay. And in some cases, in some network, you might have a switch that's in charge of layer 3. Okay. So that would be the switch that would have layer 3 and up. Some switch will go all the way up to layer 4 or even layer 5. So often you would see those switches are being used for multiple purposes, like routing within the actual network when we have separate subnet to isolate different type of access. Or it would be used for voice over IP, telephone communication inside the network. That would be your layer 4 switch. So to say mainly router function here in layer 3, or a device that can utilize IP addresses to forward packets, which is how your data is being sent in packets. Okay. And then for data translation and code formatting, especially with HTML, right? Like for websites or even for web applications, if it's using other type of programming languages like JavaScript, so you can interface with the form, that is the presentation layer. So when you see a website showing up in front of you, that has already been done. The code of the data is already translated and based on the formatting. So there are so many different ways that we can only encode something. The text that you see is ASCII, ASCII. And ASCII is limited, so we can utilize ASCII to assign specific number to certain character that the computer would understand. So when you send, let's say, a text message, what will happen is it takes those characters and it converts it to numbers, and that the number is then converted again, right, into 0 and 1. So ultimately your computer understands everything at 0 and 1s. So in the presentation layer, it takes the data packets, right, and it interprets what's inside could possibly your code, and then it's going to present it to the next layer, which then interpret it to application use for browser, for different form of application. So Then we would use the application layer. So this is layer 6, number 3, oops. And then for number 4, this is layer 7. Now, OSI model is a common model to standardize not just devices, but implementation of protocols for specific services. And then sometimes you would see the TCP IP model, which is built on the OSI model. It has less layers, and they would combine multiple layers of the OSI into the TCP IP model. So when you interview for networking jobs, sometimes they would ask you about questions
angry?
of the OSI layer.
It looks smoother.
Question. I have a question.
Yes.
How would you know if your layer 5 is not working?
For layer 5, like in transport?
No, the session layer.
Or for the session layer, if your session layer is not working, you won't even be authenticating or communicating. Like, let's say that I open up a website, right? And let's say Facebook, and I try to log into it.
Immediately. I had an update, like everything was like holding me back from getting in.
When you trying to access the web page to, let's say, check your messages, your posts, you won't be able to even authenticate or have that web page show. Now, sometimes they capitalize on the session layer in that if you have some form of attack, then they can actually take over your session. Then usually you would serve back to either a home page or reroute it to some kind of error message. So when you consistently see that you're not able to access certain web pages or web services, then you can also tell that your session is not working. So the type of attack that you often see with taking over somebody's session is man in the middle, and they would impersonate your system. So they would get your session and you would not be able to have that service or that whatever you're requesting for. So it's kind of like how if you're waiting in line for, let's say, your pizza order, and somebody comes and they tell the restaurant that they are you, so they got your pizza. So in that sense, you won't be able to get your pizza. You would just be empty-handed. Okay? Any other questions?
So, and then layer 6, how do you know if that's not working?
So you won't be able to have any session if somebody is intervening, or you won't be able to even get to your browser opening or serving web pages. You won't be able to.
Layer 6,
Yeah.
you mean?
Yeah, so session leads to presentation. And so if your session doesn't work, if your presentation is not working, then you won't have any kind of formatted page showing on your browser or any type of communication established. Even on the voice over IP level, you won't even be able to reach whoever you're calling.
So if I'm on Yahoo and it just shows me a list instead of showing me the pictures, is that?
It's a formatting issues, and that goes back to your applications, possibly that you don't have the proper add-ons for that browser, or you disable a certain type of add-on, so the code is not fully translated.
Okay.
And yeah, some browser would require specific add-ons. So some website, they would use Java, which is old. People don't use Java anymore. What they would do is they would use HTML5 with other languages. So let's say that I don't install Java on my computer. Then when I use those applications that require Java, it's not going to fully be able to interpret what those codes are. So it's not going to give me the complete web page how it's intended to be shown. Okay. Any good question? Any other questions? So for the application, so these layers work together. So if you're missing one, then you're not gonna get communication across. It's designed to implement, and there's some device that's only gonna work in the beginning layers, but your computer, especially when we use it in a browser perspective, you use all layers and go back and forth each time. Okay. Okay, so make sure we know all the 7 layers. So the way that one of my friends in school helped me remember this is to come up with a little funny saying using the first letter of each one, okay? So she told me to say, people don't need to see purple alligator. And that's what I always remember since my days in college when I think about OSI, okay? So people don't need to see purple alligator. And there are other books and things on the internet showing you how to say this with the pizza, right? But I've always remembered this way. So once I have the first letter, then I can fill in what that is. Physical data link, network, transport session, and
Hello?
okay, any question? Okay, so I'm gonna mute everyone. If you have questions, you can unmute, okay? Just to make sure that we don't have interference with noise in the back. Okay, so in your notes, it seems like it's long, but it's not. I added a lot of the different pictures and things to represent the OSI layer. And this is a logical implementation. So you don't really physically see a lot of these things that's happening in the background using the protocol. So we'll go over protocols next week. And also we'll talk about it in the lab. Okay. So now, keep in mind that the OSI model is a way that we can implement uniform standardized development and standardization. So when you start working for companies that produce, you know, network adapter cards or even, you know, processor for specific type of like chipsets for adapters, like network adapters and things like that, you would see that they have to follow the standards to make sure that it, you know, it can be installed in any system and it will work, even in Apple sense, right? Where Apple makes unique devices, but their iPhones and their iPads and their, you know, iMac that has the same standard in how they design their network interface and their Wi-Fi adapter. Okay. Okay, any questions? All right, so here's some pictures for you to show you. So when you print, when you're messaging your friends, when you're chatting, when you're accessing database, stuff like that, right? You're at application. When you encrypt or decrypt data or you compress file, that's actually presentation and application. When the system have dialogue control with how it communicates that session, end-to-end connection, routing, framing. So here it gives you the details. Okay. Okay, so that's the OSI layers. And this is, if you don't understand this part, it's really hard to visualize how the system would communicate and transfer data across. And in security, this is, you know, we go back to the layers and looking at, you know, the weaknesses in different protocols that's tied to specific layers. Okay, so whenever your system sends, especially with the TCP, which is the transport layer, it has to have confirmation. It's like how you send a package to your friend using UPS, FedEx, or the post office. It's a way that we can track to make sure that that package gets there. So when your data is framed, it's in pieces, like I said, like different parts of the bicycle. But when it gets there, it's going to reassemble everything back to give you the entirety of the bicycle. So in order to do that, the system has to send saying, hey, I'm sending something to you. Okay, like the router, and the router can forward that to the next device and so forth. Then the receiving system would say, okay, I'm ready. Then once the receiver or the sender sees the acknowledgement, then it's going to send the data. It doesn't just send on the whim. Okay, so that way we have to make sure that the connection is established. This is when when you see error on web pages and stuff like that, it has to show that it did not get to that web server, and you're gonna get, you know, an error on your screen. Okay, so no data was sent, so you get some kind of error message. Okay, so connection oriented sessions are essential. We use this every day, from the time that you check your email to when you go on social network. So it's a way that we can synchronize, right, to make sure that the system is knowing that we're gonna send. It's a way that we can sequence, making sure that the data comes back in order. Because if you don't have that, your bicycle won't be a bicycle, right? The handle would be in the wheel, and the wheel would be in different areas. So we want to make sure that we have everything back intact. And this was how it was created since the 70s going toward the 80s. Okay, and we've always used it since. So for flow control, this is a way that we can make sure that our data is not lost and our data doesn't flood the other system. Meaning that when you're trying to send, you don't want to send too much, right? It's that once the system receives, it's going to receive it to a certain extent, and then it's going to tell the sender, hey, I'm full, wait, okay? And this is what you see a lot too when you're getting video, okay? When you click on a video, the entire video doesn't arrive at once, okay? Even when you're downloading, it's downloading by pieces. So what happens is there's a form of flow control, so that way you're not getting flooded all at once from the sender, right? So now on an attacker perspective, right, you can still flood a system this way if you just continues to send. And the receiver always going to try to listen and say, okay, I'm ready to receive. And even if it's not ready to receive, if they continue to launch the request, eventually it would exhaust the receiver. Okay, but we do have a form of controlling how the data flow across the network. Otherwise, you're going to have congestion all the time.
Is that kind of like a DDoS attack?
Yeah, so even with the DOS, so distributed denial of service is many systems sending, right? Because we do have flow control from one recipient. So they capitalize on that. They say, well, if you have controlling from one system, if I'm sending it from 1,000 system, right? We're gonna exhaust your system. Okay, so you're gonna target one. It's kind of like, you know, if I have one child, right, that's crying, that's asking for something, and I'm trying to fulfill that child's request, then all of a sudden now, if I have 1,000 kids start crying and asking for different things all at once, and how am I going to be able to manage that, right? I can have flow control to fulfill the request for that one child, but I won't be able to serve all the 1,000 kids all at once. And it's the same approach. So distributed, yes, it would request continuously, so it exhausts, but because they implemented flow control from one system, they can manage it from one sender.
Question?
Other question? Yes.
Yes. Can you write a Python script to prevent a DDoS attack?
Yes. What you can do is you can look for a specific type of request, and then you can put in the condition. If it sees that type of request, it's going to reject it.
Great.
Okay. Yeah. We'll talk about if you take CIS824B, right, you would see more of that. Those are going to be the programs for security. And then CIS824B is for network scripting, like automated with network, like adding devices, you know, IP addresses, those type of stuff. Okay. Okay. So to answer the next question, in a connection-oriented session, why do hosts establish connection parameters? It's a way that we can establish rules for the connection, so that way it could be accepted. And we can synchronize data before we transfer it. Okay, so it's like how you're looking at people running the marathon, right? The person before they handed the baton to the next person, they say, hey, here's the baton, here's the stick, right? You need to hold it a certain way, and you need to make sure that you get it to the end. And then the recipient said, okay, I'm ready. Give them that, and then that person would just run it toward the end of the track. So we got to make sure that the data is synchronized appropriately before we can send it. And we have to make sure that we are connected before we send it. And that's oriented. So certain protocols are, and certain protocols are not. Like TCP is connection oriented. IP is not. Okay, we'll talk more about protocol next week. Any question on question 6 in the assignment? Okay, and when we talk about flow control, so it's a way that we can govern the amount of data sent by the sender, and it prevents the sending host to overflow the buffer of the receiving host. And you do see buffer overflow, right, in application, also in, that's a flaw for the you know, the developer, the creator of the application. You do see a buffer overflow as a form of attack in network environment. So even if we implement the parameters and the rules, it doesn't mean that somebody cannot violate the rules. They found ways to do that. Okay, the switch operates in layer 2, which is your data link. And your data has header. So think of it like how you mail out post office mail. You would have sender and recipient, right, written on the address. Who is it from? Where is it going to? So you often see this in the data packets. It's going to say who is the source, which is the sender, and who is the destination, right? And often you would see the destination would be IP address, because it just needs to get it to that network, right? That mailbox. And then once it gets there, the router passes to the switch, and the switch job is to identify where that system is inside the network. So the data link job, the data link layer, it's in charge of that, making sure that it gets to the right source, or the right destination from the source with the data frame. Okay, any question?
Yes, last week there was a homework in-class assignment question, and one of the answers was a layer 4 switch. I mean, really, what's the
Yes.
difference between a layer 4 switch and a router?
Nothing. But in a sense where people want to use a switch for like voice operations, so that way we can set up telephone in all different office in the segment, then they would use the switch. So it still can route and it still can switch at the same time. It's multifunctional. So the layer 4 switch, often that you can use it as a router, but most people, they use it internally inside the network to connect appliances and devices for a specific purpose, right? To be able to have different form of communication and different services. So layer 4 is often used for voice over IP.
Okay,
Telephone. You see that a lot in network, and Cisco has a certification for voice over IP specifically. Every network now uses voice over IP. Nobody really used the old PCB system for telephone anymore. It's very expensive to maintain now. Okay, so what type of devices operated at the physical layer of the OSI model? We talked about the network interface card. There's also transceivers. Transceivers is only sending things in bits, right? And it's very much like a dummy hub, where it just, and if you use like signal repeater at home, that's at the physical layer. It repeats your signal and it sends that signal, right? It amplifies it, it sends it to the router. Most repeaters don't work that good because, you know, when you lose signal with wireless, it's usually tied back to the physical either interference or the location. If you have a dense wall with metal plates, you're gonna get bounces signal. If if your router antenna is facing a certain way, you also get different signals. So we'll talk about wireless next week. Okay, so these are the common devices that you see: network interface card, transceivers, repeaters, or hubs. I should put that on the next one. So the hubs is different than the switch. It's usually smaller physically. It has less ports, but the hubs is just to pass that signal to the next device. It simply is a pathway just to send the same signal. The switch, the managed switch, is smarter. It creates a table of all the systems that are connected, that communicated with it once, right? And it's, the MAC address table, and it's used that to identify where those systems are in that segment. So once you have connected that computer to that switch, and you submitted something through that switch, it keeps a record of that particular computer by MAC addresses, the physical address. Okay, that's how it knows. So we can pinpoint exactly where a certain computer is using, right, switching devices. Question. And then the router operates at layer 3. Layer 3 is in charge of routing and IP addressing. Now, router, its job, like your Wi-Fi router at home, its job is just to route out internal requests to the next network. Okay, that's its job. And depending on the technology of the router, there's some router that would pass to the next available router based on first come, first serve. So all the routers, they usually advertise, they said, hey, I'm free, pass to me. Then, you know, or if they're busy, it would say, I'm busy, pass it to the next one. Okay, that's how we route data. Now, some router, you can, in most routers, set up specific route, only accept certain traffic from certain sender. And it would only route to a specific router. And this is how we can secure a certain type of network communication. So let's say that you have one system that has very important data, right? And that system, let's say the bank, they process batch transactions, right, for transfer. That transferring system would have specific route. They would use specific path to make sure that that gets to appropriate financial institution instead of passing it to all the other routers on their network. Okay. Any question? So network design is the core in security. If you lack physical and logical network design, you lack security. So that's important that you understand this before we take the next class. Okay, how does data transmit across the network? It's wrapped with protocol at each layer of the OSI. Every layer has some form of protocol. So we already talked about HTTPS at application layer, right? What if you do file transfer protocol, downloading and uploading, FTP? What if you're checking your email, IMAP or POP3, right? So in this type of job, right, you have to be familiar with the type of protocol and the network functioning for that protocol. So there are approximately 100 or less common port number that ties to the protocol. Okay, we'll talk about that next week. And we would use that number to represent the connection for that protocol. Okay, any question on OSI? So it shows you some pictures and then it talks about packets, okay? Keep in mind that your data is represented as packets and that's how it's routed. Oh, I forgot to talk about encapsulation. This is important. Encapsulation. Whenever you make a phone call to your friend or your family members, wherever in the world, right? We use digital network now. So your voice is an analog signal, right? Sound waves. Your smartphone takes, right? The microphone in the smartphone takes that sound wave and your smartphone converts that into 0 and 1s, okay? And then your voice is framed as the data packet and sent from your home network, which is your router, across multiple network, and it would get to whoever that you're trying to call. Okay, so during this process, when the host transmit the data, right, as encapsulated, it's already converted into 0 and 1. It transmitted across different type of network, and that's how you hear. We don't have much latency now because we have better, you know, landline system to support the intercommunication of all the networks. However, when you're trying to call, let's say, some part of the world that don't have good connections, you do see a lag right? Or when you video conferencing with them, you see a lag. When they talk and you don't hear their voice, right? So in the compression of that, when it gets to your system, the data is not fully synced at the right time. So you see the image and the sound because they arrive as separate packets, right? It's presented as with an offset. So you often see there's like, you know, you see this with television too. You see the image moving and then the, you know, so it's not syncing at the right time. It has some time offset when that packets arrive and reassembled and presented. Okay, so data encapsulation is how we convert our signal to 0 and 1s to be able to transmit it as data packets. Okay. All right, physical media. So today I'm only going to talk about the main three, which is what you often see in network today. Okay. Coaxial, you see this at home if you have cable television, right? It's a cable that would have a needle inside. So let me see if I can get some of this out and I can show you. And then you also have twisted pair, which is your Ethernet cable. And Ethernet cable is used to connect our computers, all types of your network devices. And then you have fiber. Okay. So my student made this from CIS824B and CIS824B. So the coaxial, you would have a needle like this, okay? And it would have a PVC plastic. And this is fire retardant. So that way you don't have fire issues, or when you have high heat, it doesn't catch on fire, okay? And coaxial was commonly used in the 90s for a lot of different things, but now it's mainly used for video purposes in a network, like surveillance systems, or at home, you would see this with cable television, okay? Cable connection, this is a copper base, and the media is important because it tells you about performance, speed. Okay, you guys know that already. You hear all the fiber advertisement. Fiber is fast, right? We'll talk about fiber. Okay, so each cable, it has limitation with data transfer rate. So it depends on the type of media that you use. That would tie back to the speed of your network. Okay, so when you look at this type of cable, I'm going to show you. Actually, they punch all of these down. So when you make this type of cable, after you cut off the plastic covering, you're gonna see there's a lot of different little metal wires that's twisted, which is copper, that's braided, okay? And you would, when you assemble this cable, you have to be careful. You would use a wire brush to brush it back. And then these are the RG59 or the RG6. These are the connectors, okay? So you have to push them in, and you would use a crimping tool to keep them in place. Okay, I'll show you the crimping tool in a little bit once I get it out of my bag. But you can run these. They are affordable. They are you know, somewhat reliable. We still use them all the time. Okay. So here it talks a little bit about the coaxial. So there are two types of coaxial. Thin net was used for like 90s and 80s. So that's the 10 base 2, okay? When you see this number 10 right here, that represents the speed, okay? And then the base 2, the 2 here just represents the type of media. So when you see like 1,000 base T, right? That means it's a twisted pair and it's at 1,000 megabit per second. So thin net was a thin coaxial. There was some limitation with that. I think we stopped really using these now, but in the early 2000s, you still see some of those. So it uses the RG58 connector. They look exactly the same. It's just not as thick and it's not as reliable. Now, when you have a bunch of copper together, you're gonna have interference, EMI. So when you have that, you have degrading in signal, okay? So be careful when you have a bunch of different network cables in your home together, right? From the router, it's okay, but when you bunch them together and you run it, let's say from upstairs, downstairs, or different part of the house, you will likely have interference. All electronic devices have some form of interference or another, okay? So a good quality cable would have a shield. It would have some form of shield inside the coating, and that would prevent a lot of interference. Now what we're using is we're using the thick net, right? Which allows us to run it all the way up to 500 meters. So when you call Spectrum or, you know, Frontier, when they come and they service your home and they run these cables, a lot of the times they use coaxial because number one, it's cost effective, right? And it's easy to install is the second thing. And so therefore we rely on a lot of the coaxial in our household, okay? So your main box in the garage or inside somewhere in your new, you know, in your parameter of your home, a lot of it comes back to coaxial, and then coaxial, they tap that into the main box for fiber. So you're not truly getting fiber, okay? So it's kind of like this. I have a big tunnel and I have water running through this tunnel. Then when it gets to your house, I'm gonna put small little hose that's gonna lead to your house. Those are the coaxial. So the fiber goes to your street and the main box of your house, in front of your house on the side of the street. And then those boxes, they're usually green, gets distributed to your house using coaxial, which is a degrading in media. So when they say that, you know, you do get decent speed, but you're not going to get fiber fully speed, okay? A true fiber is fiber to the home. You have to have a termination box of fiber. And we had that installed for Parkside Complex 16, and it's not cheap, right? Fiber to install, you know, full fiber for your home is very expensive. Businesses, they can do that, right? So here's coaxial, that's what it looks like. Okay, so you have the plastic jacket, and then you have copper braiding, which is the metallic shield, right? That's why the thick net is better than the thin net. Didn't have too much of a shield. And then you have the dielectric insulator. This keeps, right, the inside the central core cool, okay? Which is often, you would see it's almost like plastic-like. It's white when you cut it. And then you would have the center core. And I tell my student, when you assemble these, try to leave like an inch of the center core, you know, peeking above, and then you can trim it off. And when you trim it off, you have to cut it straight. So that way, right, when you have full contact, when you plug that into the female from the male, okay? So most of the time you would see your cable as a male using a male BNC connector. So I showed you, right? So this is a male because it has a needle that's gonna go to the connector, right? Whether that will be your TV or your cable box, or could be, you know, like a splitter, which has multiple female connection point, or to the wall jack, okay? So when you install the wall jack, that will be the female, right? That's adapted to the jack. Okay, any question? Okay, so let's answer the question real quick. So you have two types of coaxial, thin net and thick net. Thin net is old, legacy. Thick net is what we use, or even better than that now, right? So thick net is more reliable. You can run it longer in length. So on page 6 of your notes, it gives you a little chart. It shows you what type of RG rating or connector that you would use. This is important to know because a lot of the times, let's say you want to make a cable at home, right? You have to buy the right connector. So currently, right, if we install it for cable television, we can use the RG59 or the RG6. They look very much the same. Excuse me. Let me see, who's that? Okay. Then, so if you're making coaxial, right, especially for long distance, let's say that you have a guest house and your guest house, you want to tap that back into your main house to have television, right? Then you can run the cable coaxial to the guest house, but I would recommend using RG6, okay? You can also use RG59, but RG6 is more reliable because the way that they made the connector, right, it's able to handle specific connection for longer distance as far as how the signal passes. Okay, you can also have the power implementation with that. We don't use RG62 anymore, but back in the days, we would install using RG58. Question? Okay, so your Ethernet cable is the shielded twisted pair, your STP. Okay, I'm sorry, unshielded twisted pair, your UTP. The shielded twisted pair, you do see some of these, and these would have foil wrap inside the plastic jacket. It costs more to produce, so most of the time when you buy Ethernet cable or when you buy something that comes with an Ethernet cable, it is unshielded. So what do I mean by that? Okay. When you have a cable like this, and it can come in any color, when you take off the plastic wrap, you would see that it would have a foil wrap inside that's shielded. It's used to protect interference, right? To reduce interference. So now the cable that you have that you use for your computer at home or your router at home, those are UTP, okay? And like I said, if you see the number in the front of the base, that's the speed. And the letter after the base, that means it's a type of cable. So T stands for twisted pair. So what do we mean by that? We actually have the pair of wire, copper, twisted inside the jacket of the cable. Let's see if I have one that's pre-cut. I don't have one. I'll take some out. So that way you can have them twisted together, and each of the wire represent a certain type of signal. It carries a certain type of signal. So your cable at home is what we call a straight through. Okay, a straight through meaning that it goes from wire 1 to wire 1, wire 2 to 2, and so forth, and they are color coded. solid and stripe in different color. Okay, orange, green, brown, blue. Okay, so you would have 8 wires, 4 pairs, and your cable at home is called straight through. So what do we use for straight through? We use when we connect different type of devices together. A computer to a switch, right? A switch to a router, a computer to a hub, and so forth. You would use a crossover UTP if you're connecting the same type of devices. A switch to a switch, a hub to a hub, okay? A router to a direct host, a computer to another computer. Now, some device would already have that capability that's built in that it will switch the signal for you, right? But by rule, when you connect your computer, your laptop to your desktop to transfer, you have to use a crossover cable. So there's specific wire that's being crossed, okay? Okay, you have any questions? Now also in the market, when you're buying an Ethernet cable today, you're gonna see that it's a Cat5e, okay? Cat5e was implemented for a long time now. It's able to give you the 10,000 base T, which is what you see is in gigabit Ethernet, okay? It's rated at higher frequency, and also it can transmit all 4 pairs at the same time compared to the older category. Your telephone cable is a Cat3, okay? It uses the smaller jack, it uses, or the connector, it's used RJ11. The Ethernet cable uses RJ45, okay? So let me see if they can actually purchase the kit for me before the course ends. If they could, then I will let you know. You can come and borrow a kit and you can make your own cable. Okay. Now also currently in a lot of the networks, they upgraded to Cat6, which is also still the same speed, but you have higher frequency, so it has higher throughput. And Cat6 cable and connector is slightly different. It's better than Cat5e. Okay. 6A and 7, you don't see them being used so much right now, right? But eventually we will have different categories. Question? So, Ethernet cable, UTP, Cat5e, or Cat6. That's what we see in the networks today. Okay. 10 years ago when I teach networking, that was different, right? It was Cat5, or even, you know, Cat5 was used for a long time, so, but it's still UTP. Any question? So I want to show you the type of tool that you need to make the cable. Okay, so this is a jacket remover. Okay. It has a blade inside, and what you do is you would take a cable like this one, right? You can use wire cutter to cut it from the box. You will put it into here, right? So there's different little holes for different size cable. So you see how there's a guard? I'm gonna put it to the guard, and that's gonna allow me to cut it off the jacket at a certain length. Then you twist a few times, right? See how It fell off. Okay. So you can also adjust how it stops. So there's different type of sizes for the jacket remover. So these are about $5. Now you would see these little insulated fiber pieces inside the cable, and notice that it's twisted. Okay. So after we remove the jacket, we would untwist it, and then we would arrange it based on whether it's cross through or crossover or straight through. Then we can insert it into the connector. Question? Okay, so that's how you, and if you also have this type of crimper, it also has a razor blade right here. You can use it to take off the jacket as well. But this is designed to crimp down the connector once you have the cable inserted. Okay, so this is a crimper. So once you have it inserted, you would press it down, hold it, and it would crimp all the wire into the connector place, right? It would click, and then you would have your cable, and you would do it for both ends. So to make UTP, you would need something to strip the cable and something to crimp the cable and the connector and the cable, of course. Okay. You can find these at home improvement stores, online, and so forth. For the coaxial, you would use a crimp. This is a crimper for coaxial. So the connector would go through here. Okay. And then once you brush you cut the jacket using also the jacket remover, then you can insert it, and when you press this down, what you do is you punch or you crimp the connector to the plastic jacket. Okay. And you can also find these at various home improvement stores and even online. So those are the type of tools. So normally I would recommend like a wire brush, you know, a wire cutter, some crimpers, and then a cable tester. Okay. Now UTP, sometime you can find cable tester for a few dollars. I picked some up, and it's battery operated. Let me see if I can find one for you. And then sometimes you can also have cable tester that are for multi-type of cable, from telephone to other such. So if you plan to do this as a job, I recommend that you would also have these in your toolkit to be able to test your cable. So just to show you real quick, these are the ones that would go into the jack. So you would get the jack plate, and then so when you install these into the wall, you would wire them up and attach them to these. Okay. And then you would insert it into the plate and then screw into the plate after you drop it through the wall. So you would see various ones like these. They have different types, different sizes. So this is for Cat 5e. Okay. So it would be something like this. See that? So this would be something that goes into the wall. Any questions?
Could you also use a multimeter to check for wires to see if
Yeah,
it's passing?
it's harder to do with the multimeter. All the multimeter will tell you is and for the straight through, it's just the presence of signal. So if you can look at the arrangement, and sometimes it's hard to detect once you have it inserted into the connector. Then you would, yeah, but multimeter would allow you to check if the signal is present. Yeah, you can do that if you don't have a cable tester. But you can find cable tester cheaper than multimeter.
It's funny, I just had to buy a multimeter for that TV repair I talked to you about. So that's what I was wondering.
Yeah, so multimeter just gonna see if there's electrical signal that's present. So you will be okay with that.
Thank you.
I'm getting all my tools out now.
Question.
Yes.
I was at a thrift store and I found a brand new, really old Ethernet cable extender.
Okay.
Is that something that, is there like a bad thing to using that?
No, I mean, it should be okay if you turn it on and you can test this to see if you can have signal. And
No,
if you don't,
it just connects to Ethernet cables.
yeah, you can do that. But you know, the longer you go, the degrading of the signal and everything. It's kind of like you have a very long hose and you turn on your water, right? The longer the hose, the end of the hose, you're gonna get less of the water coming out. So these cables have limits, so 100 meters for Ethernet. So, but yeah, you can use it to extend. I would rather use a hub to do that if I get if you need to do that, okay? Okay, so you also find stripper like this, okay? These are for like other electrical wire, but when you take off the UTP, it would look something like this. And this is one of the ones that I think this is the one I cut, but some of my students, when they take off the jacket, they go too far, so they nick the cable so that you would see like cut marks on the wire. That causes issue because you would get wire breaking and you would lose signal that way. You don't have to strip the end. You just simply take off the jacket like this much, and then you would use a connector. This is an RJ45. It's larger than your telephone connector. Then you gotta arrange it very straight, and then you would insert them. Okay. And they all have to reach the end. So you have to insert them into, and it needs to reach the copper part right here. Okay. Now it's always going to go from the arrangement. If you look at the diagram for the color coding for RJ45, the tail is always on the bottom. It's going to go from left to right. So for the straight through, both sides are exactly the same. The crossover, one is different than the other. Okay. So once you crimp it, you would see this line right here pressed down on the plastic jacket. Okay, so it doesn't come off. So if I can pull it off, that means that the cable is no good. So I just looked online the other day. There's a job opening for networking for entry level, right? And they want you to know how to do cabling. So this is a good skill to have. And if you want to apply for Spectrum, Verizon, they train you to certify with them. However, you would, you would have to know how to make cable. So this one is a tester for coaxial. It will look something like this. Okay. And then there's button for you to do the fault check. And then let me see if I can find the other cable tester, but you can also find them online. Micro Center, they sell them for like less than $10. I've seen them there. Also on Amazon, you can find them. So RJ45 for number 14. And I bought these from online, but there are local stores, like I said, Home Depot, Lowe's, they sell them too. And you don't need these many. This is if you want to create many cables for your network. But it would say the category, and the type of connector. Question?
What's the best remedy if, you know, I always break the clips off those connectors, the RJ45.
Don't pull so hard. Yeah, so sometimes you get residue in the connection area, but it's when you break the clips, it's because when you pull so hard or you press so hard. So just be careful. Now, not only that, you can also damage the actual device that it's connecting to, right? Whether it's your computer or it's the wall plate, because if it breaks off, there could be pieces of it still stuck in there, and then you also have degrading of the signal that way. Okay. All right, any question? Okay, so we need to use a crossover cable to connect to the same type of devices, a computer to a computer. We need to use a straight through to connect different devices, a computer to a switch. Okay. Question? I have previously. So I have an adapter, right? You can convert coaxial to Ethernet in the case where if you want to change it. You're still going to be limited to the coaxial connection, but you can also get an adapter like that.
When would you use that?
Let's say that I want to tap the box to possibly, or my other device doesn't have an Ethernet connection, like an older computer. It would have like coaxial. You see that with some sound card and video adapter, it would only have this. Okay, so you can adapt it to so that way other system can connect, or just to extend it to. This is, yeah. So this is a different one. This is a screw-on RG6. Okay, compared to, so you see a little bit different in the connector compared to the other one. I drop it on the ground now, so you can see the difference in that. This is the one my student made, so you can see the little wire coming out. They should have trimmed this. I used to grade them on how to. So you gotta make, so you pull this back and then you crimp it using how that's done. Okay, so you take the connector, you insert it. The needle right here needs to go above the connector by maybe less than half of an inch. An inch is too long. Then you make sure you push it into place by making sure that this, right, line up like this, and then you press down. So it would actually push everything back. This one's already crimped, so it's a little loose, but you know, so that's how you would crimp the coaxial. Okay, any question? Let's see if I brought any kind of, I thought I did, but I meant to bring some of the fiber optic home. Okay, so next let's talk about fiber optic. So you know that there are jobs for fiber optic installer or to run fiber optic with Verizon. It goes for at least $50 an hour certified, because fiber optic splicing, even though now we have the tool and the technology to do this, it still requires skills. So fiber optic uses light pulse. And now we have different grade in fiber optic where it would use LED or laser, right? But ultimately it's glass. So therefore, when you splice it, you have to etch it. And So there's specific technician that's certified to do fiber optic. Not everybody can, right? When you have people that come out to install fiber optic, or when they run fiber optic line, right, for a certain business, sometime you would see that they would have a roll of a huge set of cables, so they can go from one location to another. Like, I was watching TV and they said that some island, right, in the Bahamas, the people there, they're so wealthy that they run fiber optic to get the internet to their homes. And you can have them run in the tunnel in the ocean, you can have them run, and that's how they're able to set up connection for different part of the islands that way. So light pulses is transmitted in the fiber optic cable. Now, when you look at the information that's giving you in the notes, okay, fiber optic gives us the best transfer rate. However, right, it's hard to install, even though you don't have interference, and you can go up to 40 kilometers. So at the end of that 40 kilometer, we have to patch it. We have to run a new line. Okay, so 25 miles is quite a lot compared to Ethernet or coaxial, right? For reliability of your signal, it's great. Okay, everybody wants fiber optic now, but even though it's more affordable than before, it's still pricey. So it's more expensive than your UTP or your coaxial. Troubleshooting that can be difficult, okay, compared to twisted pair. You don't just simply use, you know, a meter to read if there's electrical signal. They have a specific, you know, way to detect the light sensor, and when we're using light speed, fiber optics is better. So it's harder to troubleshoot.
Is there an adapter so that you could use a fiber optic cable just at home?
Yes, but you have to have, like, on your computer, you mean?
Well, to
You can
connect it.
adapt. Yeah, you can adapt it to your wall, but most of your computing devices don't have fiber optic appliances enabled. Very rare. You see it on a router or a switch, but you don't see it on like computing systems. So even if you adapt it, in my opinion, when it comes to your house, it's already at coaxial speed. So, you know, it's like going from 5 lanes to 1 lane. And so it doesn't really, you're not really getting a full fiber optic, even if you adapt it to fiber optic, you see? So you have to like rip out all the coaxial line from the box in the street going to your house in order to make it fully fiber.
Okay.
Yeah, you see? So it's don't, yeah, until they upgrade it in that sense, we can't really, you know, that would just be a waste, just to have an adapter inside your house that's only gonna go up to coaxial speed. Okay, so single mode and multi-mode. Single mode, it has one core inside and it uses LED. It can transmit way better than the multi-mode, right? However, it cannot go in farther distance, okay? It can transmit 50 times farther than the multi-mode, but the multi-mode is not compared to the single mode. So in the single mode, it's high speed, long distance, and it consists of a single strand versus multiple strands. Most businesses, they would use a multi-mode, okay? So you would have different light sources inside the cable where you would have different core, and it uses like a reflective, so that way it would be able to reflect the signal back, okay? So MMF is able to go up to 3,000 feet, okay? And so for like MVC, we chose MMF for Parkside Complex 16, and we tapped that into the main fiber line for their network over in NOC, which is if you go behind the SAS building. So they had to run that, right? And they have to dig up the ground and run that through, and then they would have a panel and they would patch it, and it's gonna look something like this in the next few pictures. Okay, so when you install, when you open up those conjunction box, it looks like that. Okay, so if you drive through town, right, and if you look at like near freeway entrances and larger street, there's like a brown or green mat like cover. It's about, I want to say 5-6 feet, right? That opens access to communication tunnel. Once that opens up, you would see like a ladder or some way to get down. And in that, sometime you would see, I know in Loma Linda, because I've been down one, you would see like lines and sometimes even system that they control, you know, some of the communication line. City of Loma Linda has their own fiber, and it's been up for a long time. But you do see that throughout various cities, so like Riverside, Moreno Valley. So if you pay attention, sometimes they have plants covering it because they don't want people to access it, and of course it's secured, it's locked. On the sidewalk, you would see these little green boxes. Those are the coaxial drop that's tapped into some of the main ones that goes to all the houses in the street. And if those boxes get tampered, sometime, you know, you have loss of signal, deterioration of the cable, then you call the technician. They can also adjust the speed right there too, in some cases. I know Charter does that. Okay, so here is what you see with the multi-mode. Any question as far as fiber? So there are different types of connectors for fiber. You have the angle physical contact, and then you have the ultra physical contact, which is straight. So with the angle, the ultra polished connector, where it's just gonna be flat compared to the angle. So if it's at an angle, it's able to be more receptive of it. Okay, so those are the APC and the UPC. It will look like that. Okay, you know it's a fiber cable when you see the connector like this, and they are in double strands. Okay, so you can buy them at Walmart, you can buy them in different stores, so you can find fiber, short fiber cable for $10-15 or even less. So the ST is AT&T made. Okay, and it uses the B and C attachment. It looks like the coaxial attachment. Okay, and then Lumens, I think, is the other one that designed the connector. So there are only certain communication company that came up with the design for a certain connector. So you would also see it like this. This is the SE connector. This is some of the later ones, and it has a square. So it has a clip right here, so you can slide it back and forth, so it will clip that in. And then the later ones here is the MTRJ and the LC. And it will look like that. Okay. So these are the mainstream, this is what you would see with fiber optic. And this one, you don't need to polish, or you don't have to have epoxy. It's easy to use. So a lot of the times they prefer to use this compared to the others. Okay. So going back to the last question, right? Can you get something that adapts? Yes, and likely that you would see that it's adapt to RC or LC, not RC. It will be like this. So when you see them attached together like that, this is the LC. Okay. So now we would know a little bit more about fiber. Okay. So every home that would have fully fiber would have a panel. But you often see this more in business environment. They would have a fiber panel. And their fiber panel could be on a switch like this, or it could be just a box, like how you have electrical panel, but you would have these little fiber strands that are running in. So the panel itself, the patch is right here, okay? And this, I use this picture because I want to show you that when people say about their backbone network that's fully fiber, it would look like this on a rack, okay? So they would have network appliances that are patched for fully fiber. These are fiber strands, not RJ45 and Ethernet. Okay, and you can tell by the connector. Okay, much faster than if we're using, you know, other form of cable. Now, a lot of times they would secure this. This would be in a room where it's locked, or if it's a box, then, you know, they would put it inside like the garage or in, you know, in a closet where the business can secure it. Because if I wanted to disable that business, I simply cut this. So a few years ago, somebody found his way down these telecommunication tunnel. And you know that Cox owns a huge amount of fiber line across the United States. So he went and he cut all the fiber line, and it crippled many businesses in both coasts, West Coast and East Coast. And this happens like, and so it just, everybody went on a stop. No network communication from network to network. Okay. So, okay. So for the transceiver, you would have either a simplex or a bidirectional, which is a duplex. It's one way or both ways. Okay. And you would use something like this to be able to establish the communication. So you would have fiber line, and then when it transceives, you would use a way to control the wavelength, so that way it would either go one way or both ways using a receiver. Okay, and in this picture it uses laser. Not all fiber uses laser. Okay. Okay, so the advantages of fiber, we need to put that number one, it's reliable. It's immune to interference. That's the second thing. It's fast, definitely. Okay. Because with coaxial cable speed, we often see going up to like maybe 20 megabit per second. But if you want it more, right, then you have to get it faster. So we now rely on faster because of fiber. The disadvantage is going to be high cost, difficult to troubleshoot and install. So when they cut it, they cannot just simply use, you know, a wire cutter like this, right? You got to make sure that because it's glass, you have to edge it. And when you splice it, you would use a certain tool to cut it and splice so that way it's even cut, and then you can add connectors or patch it. Okay, so for what type of fiber optic provides fast speed and connectivity, you would rely on single mode, which is faster. But for the long distance from 1,000 to 3,000 feet, you should use multi-mode MMF. Okay. So when you connect building to building, like at university, or if you go to like Google campus, okay, or companies that will have major buildings that spread across, you know, miles, I've been to Cisco campus and it goes like 10 miles radius. It's just building after building after building. And in between the buildings, they would, or even inside the building sometimes, they would use fiber. Google had put some of their network onto a ship and it floats in San Francisco Bay because open water, it reduces tax for them. So now we started to see data center and things that are more mobile. And with mobile, we have to use satellite, but satellite is unreliable. It depends on the weather. It depends on, you know, the way the satellite is angled. So what we can do is we can rely on different panels with fiber and attach mobile data center and mobile backup sites that way. Okay. So, because if we rely on cell tower, they could bomb the cell tower. There's a lot of different things to consider when you're looking at like communication for the rest of the world, like Verizon, AT&T, T-Mobile. They gotta make sure that they have backup options in case something happens to their cell towers and their main network. Okay, questions? Okay, so this is a fairly, I want to simplify it so that way it's easy for you to understand. Anything that you have on the question, the Q&A for us, the assignments? Okay. So let's, what we're gonna do is we're gonna take a break before 2, and then I will talk about the lab and give you time for the lab using practice lab. So we're gonna do that this week. Okay, so let's take a break. Let's be back. Let's see, it's 40 now. Let's be back like a little bit before, a few minutes before 2 is okay. Okay? Okay.
Yo construí 2 veces, eran 20.
Okay, so I think we're starting back up in a minute or so. So I want to show you some of the tools that you will see as cable technician. So earlier we talked about the RG6, right? These are the connectors for the coaxial, okay? And this end goes to the back. Actually, this end goes to the front, and then this end goes to the back. So you insert it and you crimp it using this, okay? So it would sit like this, okay? So usually they would color code it for you, either black, blue, or red. So that way you know, but once it's crimped, this part is gonna go hold down your cable. This is a female one. Okay. Okay. This is an impact tool that's used for fiber. It has the blade in the front, and then it would have the dial for low or high impact to cut. Okay.
Okay, she's talking about.
Yeah. So I have an impact tool for fiber. This allows you to dial for low or high impact. And then this is an older tool that was used to cut fiber. This is a hand tool. So you would have knobs to dial right here. And then what you have to do is you have to line it up straight before you cut it. So this allows us to scope and make sure that it's dialed straight. Okay. Now you have machines that do this now. However, this is one of the older tools that was used for fiber. Okay.
How can I make your screen so that it's my main screen? Because I keep on getting the interpreter as a main screen on my Zoom.
I have set it that way so that way the student can be interpreted.
Oh, okay.
Yeah. I know I'm on a small window. It's okay. Okay, so this is a cable tester for UTP. It comes in a box like this. Okay. You would use a 9-volt battery. Okay. So once you attach the battery, you simply put it into the battery holder like this. Then you put the cover back on. You turn it on. So it should be blinking. Then you take a cable. I'm using a out of the box cable here, but in the case you make a cable, you insert it to one end, okay? And then you would insert the other end to the other part right here. And then you read. A straight through should give you all signal coming from bottom up. If there's any missing light on either side, then that means your cable is no good. Okay. The cross through, as you see in the diagram, it would cross the signal. So the 1 with the 3, the 2 with the 6. So you have to read the signal to make sure that the cable is good. Okay. And you simply insert it like this. And then you read the signal. Any question? Okay. So we would test our cable before we plug it in, especially when you're doing network installation. And that's basically it. I think those are the tools.
Professor?
Yes.
Yeah, the interpreter's screen is black on mine, where her screen is small like yours.
Oh, okay. Let me repin her. I didn't make her co-host last time, so she could control. Sorry. Okay, so now I have both of their screen. I'm not sharing anything yet. So any questions as far as the tools? Okay, so I'm gonna touch on the lab now if you don't have any questions about our lecture. So in our lab this week, we are gonna use Windows System to look at the OSI layers. You would find the lab link in Canvas. Once you click on lab, week 2 lab, you would be able to click on practice lab link. If you took the last class CIS824A, you should see this already. But if you haven't, this is what the practice lab would look like. Now keep in mind that you need to make sure that your pop-up blocker is allowed for practice lab. So if it prompts you a little message, make sure you click yes to allow practice lab. Otherwise, you won't be able to see the window. And the instructions is built into practice lab in the pages. So follow the pages. It will ask you to do various things, including the assessment. Then when you're done, click done. So I open all of these lab until the 18th because I have to submit your grade by the 20th for this class. So make sure whatever you do, get the lab completed by the 18th. Okay, but try to do it this week. Okay, so at the beginning, there's some tutorial how to use practice lab. This module comes from the latest training for Network Plus CompTIA. So you're getting the training that a person would acquire if they want to prepare for the N1007 Network Plus exam. Because in the current exam, not only that you have to answer questions, but you also have to illustrate that you can configure or be able to troubleshoot networks. So on the first page, it gives you the detail about the certification objectives. This lab is supposed to only take an hour. It also depends on your connection. Sometimes practice lab can be slow. If you have any issues, there's the question mark, which takes you to help and support. And then you can also look at your status, but the drawer right here allows you to access other resources inside practice lab. Next, your lab instructions doesn't start until about page 2 or page 3. In the middle here is all the virtual machine that you would utilize, sometime not all, sometime all. So make sure you look at the instructions. So in this lab, you are going to use the BDC01, which automatically turns on once you click practice lab. And it's going to use a virtual machine that's Windows 10. Okay. Now the IP address for that virtual machine is 192.168.0.4. And it's in the segment. Now the server IP is 192.168.0.3. Now server, we don't use dynamic IP. Your public IP is going to be assigned to you by your vendor or your provider. So that also is maintained by your provider. Inside your network, you would see an IP address like these because those are internal IP to the network. So they are different. Okay, your private IP is different than your public IP. Some of you know this when you're looking at your configuration at home. So now we'll talk about the addresses and the class of addresses and how to use those in the next couple of weeks. But basically, the administrator or the person that manages the network at home or for business, they determine based on the number of systems that are connected as IP addresses. So some class would have more addresses to use compared to other classes if we're looking at version 4. In version 6, of course, you have larger address scope because there's 128 bits for each address versus version 4 is 32-bit. So the beginning task 1, it just gives you the review on OSI model. And compare that to the TCP IP model, you see that they simplify that to only 4. And sometimes you do see representation with 3 layers. But the standard TCP IP model is 4 layers. And that is combining some of the traditional OSI model. Okay, so that shows you the difference there. Like for example, in OSI we have layer 5 through 7, and that belongs to the application for TCP IP. Internet will be 3, and then link would be layer 1 and 2. So they combine some of these to make individual layer for TCP IP. Okay, and Network Plus does ask about both models. And then you also see sometime in 5 layers. Okay, so that will be the breakdown here. Okay, so here's some diagram and it talks about the order of the OSI. Then in exercise 2, I want to demo some of this real quick. You are going to use the BDC01. That's on. And then the Win10. So we want to turn that on. Okay. So make sure both of those machines are on. Then in Windows 10, once that's turned on, it's going to pop up and that will allow you to be able to access the network and open sharing center. I was testing these, and sometimes you don't see the icon. You just click on identify the network on the right of your system tray of that virtual machine. The big thing that I want to point out for most students is that sometimes they mistakenly click their system versus the virtual machine system. So make sure that we check. And so when let's see, here's my Windows 10 virtual machine. Okay. Now, if for some reason you get disconnected, you can click the little lightning bolt, right? But it should automatically log you in. Now, in the screen capture, they show little icons here, but on their virtual machine, there isn't. So you simply click this to access the network, and then click network settings, okay? Because it's not exactly like how the instruction is shown with the screen capture. So click this to identify your network, and then click new network settings. In here, you would see the network sharing center. And we would utilize this to troubleshoot Windows settings for networks. For example, I can look at the IP addresses. I can establish a certain type of connection. Okay. So if you want to change the settings for the network in Windows 10, once you get into Network Sharing Center, you can also use Control Panel to navigate to it. Okay. Then you would click on Change Advanced Settings, and it will look like this. Okay. So here we can check to see if we can turn on certain things or turn off certain things for our media. And if you expand, you would see that there's private network information for you to turn on and off. Now we want to have network discovery, so that way we can see like our router, our devices. But if you want it to be a standalone system where it doesn't communicate with anything in the network, you want to turn off the network discovery. In the case of I have like a backup server that I'm still configuring, I can turn that off, and then I will enable the network discovery later on. Because once you do that, what happens is it's gonna tell all the system who it is. So let me get rid of the updates here. Okay, let's go back to the lab instruction. So once you're in the network sharing center, what it will do is it's going to ask you to look at the Ethernet property. Okay, now depending on the system, you will likely see that on your system, if you have multiple adapter, it's going to show multiple multiple things. Okay. Now, if you have, let's say, only one Wi-Fi adapter, it's only going to show one. Now, we can tell that it's connected with Ethernet, which is through the Ethernet adapter with the cable. Otherwise, it would say Wi-Fi. So when we click on this right here, what you have is you have the detail about that adapter, right? How fast is it connecting, and what kind of addresses that it's using. You can also diagnose it or disable it. So when do I disable it? When I don't need it, right? Like in the case if I have two adapters, I want to disable one and use one to connect. We do that for security reasons, because if you don't disable one, what will happen is somebody can connect to that and be able to use it for other reasons, right? Disable things that you don't need. With the properties, this is where you can look at the details on how your configuration would be, okay? Now in the lab, it have you click on configure, and then you're going to go into the details, and then you're going to go and select hardware IDs. Okay. This gives us the identification value that's given to that particular adapter. And you notice that this is a VM bus because it's using a virtual machine that's connected to a host system, physical system, right, that actually has the physical hardware components. Okay. Now, when we go down and we would select is connected, which is what they have you select in the lab, the value for this is true. So if it's false, then the device is not connected. So going back to Michelle's question earlier today, can you do something in a script using like Python or another language to specify certain systems should be connected? Sure. Right? You can specify that to check if it's connected or not. So we can automate some of that in a network environment for all our systems. Okay. Now, sometimes you would have multiple scripts for different type of devices because as you see, each device would require certain things based on the hardware construction and also the OS or the iOS that's using it. So basically in the lab for that exercise, it shows you how to be able to look at whether your device is connected, right? And at this level, we're looking at the physical level now, the Ethernet adapter, right? Is it connected? Is it sending bits? Okay. So those are practically the steps that I show here. Then you would look at the configuration in the details. Okay. So that would take us to the end of step 8 and going into 9. Then in task 2, what you're going to do is you are going to look at the properties again of that Ethernet adapter. Okay. And that will bring you back to the dialog box and you can check out the drivers. So let's go back to that. Okay. So we simply can click on it and then go to properties. Okay. Now, if we look at configure, this dialog box pop up, then you can click driver tab. This tells you about the driver that's installed for that adapter. So when you're troubleshooting your internet connection, you should make sure that you see if it's connected, if it has some kind of IP address, and to see if the drivers are properly installed. Because sometimes if it's a brand new computer that people just built, what happens is they don't have the chipset driver installed, which is for the motherboard. And in most cases, the Ethernet adapter is built into that motherboard, even in the laptop case where the Wi-Fi is already built in. So here we would see the driver detail. Okay. Now a way that we can update driver is to click this right here, or you can use device manager. You simply search for that. Click the arrow next to the network adapter and then right click the adapter and choose update driver. Okay. Now here we can also disable or uninstall. When do I need to uninstall? When I have another adapter. Let's say that I'm using a USB one, or I added another card. Okay, and we touched on that in the last class. So in that, I think they're just showing you on how to look at the configuration, and those configuration really function within the first layer, which is the physical. Okay. Then I want to talk a little bit about command prompt. Okay. So in the lab, they have to use command prompt. And command prompt is a command line application for Windows. In Linux, that will be your terminal. In Mac, that will be your terminal. And in Linux, when we're trying to find IP configuration information, we would use ifconfig. Okay. So in my virtual machine here, I can search for command prompt or type in CMD. Okay. Instead of using this, I'm going to use my computer. Actually, no, let's use this. Okay. Now you can change the way it looks by going to its properties by clicking the little top icon here. And then I'm going to increase the font so you can see. Okay. So if we do an ipconfig space /all, we're asking the system to present to us all the configuration for the IP address. And IP address is at layer 3. Okay. Now I think I touched a little bit on this before, but in case you miss it, you would see that, let's scroll up real quick, let me try this. You're gonna get presented with all the adapters information, okay? And each one, it would specify what kind of adapter it is in each section. So here is the Windows IP configuration. This is the computer name, plabwin10. That's what is named for that computer or that virtual machine. Their domain is practicelab.com. This comes from the server that was turned on, which is the server 2016, the BDC01. Okay. Here's a mixed node type. Now we don't have IP routing for that computer. We don't need to route from that computer, so no. It's not a proxy system, meaning that we talked about how proxy would be used last time. And since this is it's connected to the domain, it's served from the BDC01, that's practicelab.com. Okay. And if you want to know more about Microsoft configuration, take CIS824B and C. So here is my Ethernet adapter. This physical address is a MAC address. Media Access Controller, that's what MAC stands for. This is a permanent address that's ingrained onto the Ethernet adapter or the adapter like the Wi-Fi. It's registered to specific vendor, and the vendor is given a range of addresses that they can use when they produce Ethernet adapter or Wi-Fi adapters. This system is not DHCP enabled, and Dynamic Host Control Protocol, its job is to lease IP addresses for periodic use. So in your home, if your router has the DHCP capability, this is why you're getting different IP addresses occasionally, okay? Like I would have a 192.168.0.7 1 week, and then next month I would get a 192.168.0.10, right? It depends on whether that IP is available the next time it assigns. Now, all our system now is capable of using IP version 6, which is preferred now compared to version 4. And IP version 6 uses hexadecimal number. And when you see the dot like this, it's a concatenation. It's a shortened address, meaning that they have a bunch of zeros in between. So instead of having 0000, we can shorten it by using the 2 colon. And each system would have a unique address, IP address version 4 or 6. We don't use the same one. So when you have a conflict of address, if you assign the same address for 2 computers, you would have a conflict, and the conflict causes both systems not to be connected. They have to be unique. Here is the version 4, which is 32-bit. And this is a .4, so my server is the .3. And they can statically assign this, meaning that it stays the same. So which system does contain static IP? The printer that you share at home now, you use dynamic because you know you can reboot your printer and it will get a different address. If it doesn't get an address, then you can't print from a network system. But they can assign a static IP for system that needs to have the same IP so other system can reach it, like servers, network printers, network copiers, okay, switches, routers. Those stay statically the same. It doesn't get reassigned IP. This subnet mask right here, it tells the rest of the system and all the routing systems that this is the network segment or zone that it's in. Okay? It's like the zip code for your address. It tells the post person, the post office person, where you are in that city. The default gateway right here implies a router address. Okay? And then you also have the DHCP. So here they use DHCP with the version 6 address and the DNS server. So you should ask me, well, Dr. Wayne, why is the DNS server address different than the BDC01 address? You notice that this is a 192.168.2, okay? And earlier in the document, we saw that it's 192.168.0.3. So the domain is using a .2 for the function of the domain name server. What does that do? It translates the name, which is the practicelab.com, to the IP and vice versa. So when you type in the address, it knows that that points to practicelab.com. So it's pinned the domain server to the .2. Okay. Now for the .3, which is the larger domain, that is a different functionality. So the BDC01 has the .3, but it can also, right, has an additional network adapter that uses a .2 for the DNS purpose only. And in most cases, your server would have multiple Ethernet adapter for specific reasons. Okay. So I want to show you this in detail so when you read it, it doesn't sound foreign to you. When you look at your computer at home, you should say, oh, this is what it means. NetBIOS here with the TCP IP is enabled. So we can also find the system by its host name. Okay, and this is their second Ethernet adapter. This is the second one. So in this virtual machine, there are two. And if you're using a virtual machine on your computer, it might say, like if you're using VMware adapter, right? VBox adapter. So it makes a logical adapter on top of your hardware to treat it as a separate component, a separate system. Question. Okay, so that gives you a little bit of detail about looking at your IP configuration. And this is a command that's very common in network troubleshooting, right? When a user called and they said, I can't connect to the internet or any of the network printers, can you please help me? And so you need to check, right, if the configuration, the settings are in place. So here it gives you a little bit of explanation on what everything is. Remember, physical address is your MAC address, your media access controller address. Okay, then I'm going to talk about ARP. So let me do a clear screen. So if you want to clear your command prompt, you issue a CLS, which is to clear. CLS, okay? Then we're going to do an ARP-A. So ARP stands for Address Resolution Protocol. This particular protocol is utilized to resolve IP to MAC address, right? And MAC address pertains to that physical system, and the IP address is used to route data from that system or to that system. So it needs to be able to tie the two together, okay? So they would use a protocol to do this, and this particular protocol is gonna work with the data link layer and communicate, so that way the network layer can be communicated, okay? So what we're seeing here is it's a table of addresses, and it gives you the correlation between an IP and a MAC address. Okay, so if I have a .2, this is the address for a .2. If I have a .50, which is my default gateway, this is a physical address. So you can technically look at all the other connected devices by looking at ARP output. As long as this, if the system is connected to network, the entire network, and all the other devices are connected, then we can see, right, which system is which address. Okay. Now, when you see F's right here, right, that's a broadcast address. It doesn't receive, it only sends. So like, think about radio, right? They don't hear when you speak, but you hear when they broadcast. So those type of systems usually just sends out information, okay? And then we also see their provider information, the 224, okay? So in that, what you have is you have an address table. Now in security, we use ARP a lot. We can use ARP to look at, right? From an attacker standpoint, I like to tell my students that, because you have to think like an attacker to prevent an attacker. When from an attacker standpoint, once they're in the network, they would look at the table to see what other devices they can access, right? And what are those devices' address, okay? And is it connected to that system, okay? So we do have some additional networks here. That's what you see outside of the 192, starting with 224. And in order to connect the 192 with the 224, it has to be routed. Okay, so when you're looking at IP, that's a network layer and it needs to route. So I need to go from my router, which is 250 on this virtual machine, and it needs to get to the 224 network, which it routes to it, right? And then it also needs to, and this is a broadcast one, so they use this. When you see a .5255, that's usually a broadcast, and the F's here, it's a broadcast. Okay. Any question? So these addresses are never assigned to specific bidirectional system, right? Like a computer where it receives and sends. Okay. So I'm giving you this part alone is usually a couple chapters for networking or network security. So you're getting like the summarized version of it, but I want you to make sure you know what you're looking at. Okay. All right. So that's ARP A. So when you do an ARP A, you would see something like that. And then it talks about the MAC and IP. Okay, so I'm going to do a ping real quick so you can see. So a way that we can check to see if a system is connected is we can ping it. It's like how you would say, oh, I'm going to ping my friend to see if that person can message me, right? So you can ping, let's say that I want to ping this itself, or 192.168.0. So if a system is connected, it should be able to listen and respond. I'm gonna make sure I type everything correctly. Okay. So in Windows environment, you're gonna see that there will be 4 packets that are sent. And ping uses ICMP. So it has to send 4 requests. It's like saying, are you there? Are you there? Are you there? Are you there? 4 times. Okay. Then the system's going to reply 4 times. I'm here, I'm here, I'm here, I'm here. Okay. So now in the Linux environment, when you ping and you don't put a counter on it with a -C and a number, it just keeps on pinging. It pings forever. Okay. So now in a packet, it has a time to live, meaning that it's going to send and it's going to live within that proximity of time. If it times out, it knows that it needs to resubmit again. So in this case, we're pinging 1 time, but it's going to send 4 requests. And with that 4 requests, it needs to receive 4 reply. If you don't get the 4 replies like this, the destination system is not communicating. It's off or something's wrong with it. Okay, so that's how we can quickly check to see if something is alive or not. Now, it doesn't always mean that all administrators would allow ping. Some network, they would disable the ping function because you can ping someone to death. You can request it forever, like I said, right? And that will be a Smurf attack. So you can keep pinging someone and it just have to keep listening and responding, and it would occupy the system in such that it can no longer be available for other communication. Okay, so with your success, you should see the packets that sent with 0 loss. Okay, but if you have unsuccessful communication, you would have 100% loss, 4 sent, 0 received. Question. Okay, so that is a little bit on ping. So it touches a little bit on that, and then it still have you go back and look at ipconfig all. Okay. And then interpreting the addresses, the subnet mask. Okay. So let me show you something in here. So we're done with command line for now. So now in the next part after that, right, you would look at Ethernet 2, and we can go into the details. So the details, when you simply click Ethernet 2 in the details, and you can do this at home too, it tells you basically in a graphical user interface what IP configuration was set. So we can see the same thing, not in such extended detail compared to the command prompt, by clicking it and going into the details. Okay, so it tells me the physical address. On this one, the DHCP is enabled, so it's getting a dynamic IP that's assigned by a DHCP role or a server. So it's leasing an IP address. Okay, think of it like a temporary address to your home, and then the MAC address is a permanent address to your home, and it needs to correlate it, right, with ARP. Okay. Other questions? Anything? Okay. So now, so after that, after you take a look at those, we can go in and set the IP. So I want to show you how you can set. And when you tweak this, you can also disconnect somebody, right? So just be careful. Okay. So in the case, let's say that I need to make the system part of a domain, join it. So in order to join a domain, you have to be part of that network segment. So what you can do is you can go into the Ethernet adapter property, and I simply click on it, right? And then I would go to properties button here, and then I click on the version 4. Now you can set it for different versions, like version 6 and version 4. So if you select that and click properties, this will pop up. Okay. Now you can tell that this system is automatically acquiring address from the DHCP server by looking at this. The second option here, right, it says it's obtain DNS address automatically from the domain, and its first option, it's obtaining the IP address automatically. So if a computer is using a static IP, they would choose this second radio button, and then they would type in the IP, the subnet mask, which is a 255.255.255.0, right? Or however they set up the subnet mask, that's for that segment. And then the default gateway would be the routing address. Okay. Okay. So if you want to set up static IP for your computer at home, this is where you would go. You would choose it and then make sure that you put in an IP that's not used, right? So check all the other devices. You can find that on your Wi-Fi router. And now with the DNS, your router at home is also defaulted with the DNS configuration too, if you set that up, right? In the case where if you do some stuff like with surveillance, like my prior system, I had it set up with the DNS. So what you would want is you can set up the static IP that way for that system. Okay. So like I mentioned before, your print server doesn't have to be a server operating system. It can be a Windows 10 or 7. And in that case, we would use static IP for that system so all the other system can use it to manage print, right? To look at print queues, to send print jobs, etc. So that system would intercept all the print queues, and we can manage, you know, who's printing, and we can also kick people out from printing if need be. So for example, if somebody's printing thousands of pages, we can terminate their job. Okay. Question. Okay. So here they have you go in and put in the IP address. You notice that now it's in a different address range. So as with that, you would have a different subnet mask. Okay. And then you also have a different gateway because it needs to route from that segment. Okay, so once you put all of that in, you would click OK and then click close, and that's how you set the static IP. Then after that, you would check it by using IP configure on command prompt, and it should update that address, right, for the Ethernet 2. Okay, so you would see that there, like their screen capture. Any question? Okay. So once you get the address, don't forget to click this take screenshot button so that way you can get credit for that task. And then on the next part, you would do a Netstat. So let me go and show you how Netstat works. So this gives you the statistic of all the connecting devices to the system. That it shows active connections, that's what it is. It does take a little bit of time, okay? Because we're using a virtual machine and we're accessing it through the browser, so be patient with it. Now, if you do Netstat on your regular system at home, you're gonna see that it's faster, and it would give you a whole new set of information. It's different and it's longer because it depends on who you're connecting to, websites, servers, you know, etc. Okay, so here we see 4 entry. Okay, and we would notice that this is the virtual machine IP, the .4. Okay, so what it's saying is that it's connecting to 10.44.24.60 that was established. And with TCP at the transport layer, there gotta be a confirmation before data was sent. So this is established. It shows you the status. Then again, I'm gonna connect to the BIOS, the net BIOS, which is another system. and there's a wait. Possibly that they enabled the service, but it never responded.
Alexa, announce Isabella, come back down.
Announcing.
Isabella, come back
Okay.
down.
Okay, so with the proxy, we establish a proxy, and proxy, I mentioned to you that it would be a way that we can route it into, we detour, right? We route it into a different area, and that's like the traffic police at the detour area. So we can get it to different part of the network, but it will still allow us to reach the destination. Okay, so that's Netstat. Netstat tells us what are we connected to. So if you wanted to know what your system is connected to, you do a Netstat. And then in any case, right, if you want help, then you just do a /help on Windows, and it gives you the overall, oops. Or the /?. It's also going to give you your, it's not letting me. I guess help will just do it. So it gives you the overall command and the description of each command, okay? And then you can do the help for each of the command as well. So here is the Netstat information. Okay, we saw that. Now I want to show you this. So let's say that we had Netstat. All right, and then we would open up their Internet Explorer, which is the browser, and then we would visit a website, right? Let's say that we would visit CompTIA. So when you access a website from your browser, it should also track that connection on Netstat, right? It would tell you that from your system, it gets to the default gateway, it gets routed out, and the server from CompTIA, the web server, when it responds, it's gonna also show the communication from your end to their end on Netstat. Okay, so in such sense, once we get with the connection, you would see that it would. I'm a little slow now because I'm on Zoom and accessing Practice Lab at the same time, but you should be able to check, right, for your connection there. And you can do the same thing at home, right? When you go on a website, you can check the network status that way. Okay. And then I showed you guys last week about using traceroute so you can follow the packets. Okay, so you would get an output like this. Okay. And if it's wait, then that means it's still waiting for response for the reply to come back. Okay. Now, if you get all time wait, that means something is timing out. It keeps having to send a request. Okay. But if you have established, that means we're connected. So UDP, just to preview for next week, user datagram protocol, unlike TCP, UDP just sends and it doesn't check. It's like sending a packet without tracking number or a way to verify that that packets get there. Okay, it's like a delivery person that just throw a packet. It doesn't matter if it's to the right house, right? So UDP is, we use this so that way it's quickly would be able to deliver instead of waiting for the confirmation like TCP. Okay, so in some services, UDP would be more adequate, like when you're watching online video or listen to iHeartRadio or, you know, Spotify, stuff like that, where it would just assemble as it arrives and it doesn't have to wait for the entire thing to actually reassemble. With TCP, it waits for all the pieces of data and then it assemble and present it. So there's a little bit of the lag in that compared to UDP. It just it receives and show, receive and show. So you're getting pieces of data. This is why when you click a video, right, you would see your little bar loading still, okay? And then when you play the video, it plays it, you know, based on what it could retrieve at that time. Okay, so for connectivity and performance reasons, sometimes we would use UDP. So here they have you check for UDP protocol only, and you can find specific protocols. So if I want only TCP, I would do netstat-p TCP. Okay. So the last part is the firewall, I think, for this exercise, this task. I want to show you real quick. Why is the firewall important? It actually checks the rules to allow or disallow certain traffic for your system. Your Windows firewall is at the simplest level. So some of my students ask me, well, is that good enough? Well, it's good enough for regular use. But in a business environment, we want to use something a little bit more heavy duty because we have different type of traffic, right, for different type of operation needs. Okay. So let's go back to control panel. So here they have the firewall on, and it's usually on by default. Unless you disable it, then you would see the red. Okay. And you would want to enable your Windows firewall for your network, your private, and even on the guest network, just to protect everything. So on the advanced settings, you can actually set up firewall rules. Inbound means incoming traffic. Outbound means outgoing traffic. So if we want to set up something that would screen for what's coming in, we can specify that. So let's say if I wanted to block certain type of protocol and services, like I wanted to block all HTTP, I could do that. I force the user to use only HTTPS. So you can have it block all the incoming for HTTP. So here there are preset rules, right? And possibly that they have modified this over time, but there are some default rules that are equipped with your Windows firewall. Okay, and you can specify for specific resources or application. Notice Microsoft Edge, right? And so forth. And then it will tell you what is that for. Is it for private network, domain, public network, etc. So you can set it for just domain or all of them, like all. So to make new rules wizard is here. And then Windows, they keep it pretty simple. You can make it for a certain program. You can make it for a certain port, which is the number that ties to that connection point, right? You can have it in using a predefined rule, or you can customize the rule. Okay. And in my security class, they play with this quite a bit on Windows level and on appliance level. So this allows us to manage access control and improve it. Okay, so that's for inbound, that's mean incoming traffic. Then we can have outbound rules set up. What can we send from the system, right? So let's say that you wanted to stop the user from sending traffic for, I don't know, videos. Okay, requests for videos, so we can also block it that way. Okay. So you can also set it up for a specific group of devices. Question. Now, with the monitoring, they might not talk about this in the lab. You can set it to monitor a specific area of the firewall and the connection. So for that system. So when we're saying Windows firewall, it's a software for this virtual machine. So if you do that for like one of the laptop or the computer at home, you can only do it for that system. Now, in the network environment, the best firewall screening is for your home right now is your firewall inside your Wi-Fi router or your cable modem or your internet modem. Okay. So what this is, we can monitor specific things for the firewall. And if it's allowed, it's going to tell you. So what does this do? It generates a log, a file that contains what's coming in, what's allowed, that's come in. So the job for the security specialist is not that glamorous. It's about looking at these files and see what was violated, right? To really detect, to see what had happened, or maybe prevent something from happening in the future. But the glamorous part is the pay, right? That's why a lot of people pursue it. So you mainly analyze how the monitoring tool is working on your system and how it's screening. And that's also could be a job for some network specialists or, you know, network people as well, if they don't have a security specific role in the company. Okay, question. So here it shows you how you can look at your firewall rules, and then you can also go to your task manager. And the task manager tells you about your system performance and also a little bit of your connection. So a trick that I show this in my other classes, I want to show you. Remember the name. Let's do a task kill. You can also access the task in command prompt. So if you want to kill a task, you can issue the command for it. But you need to find out the ID of that task. So when do we really end the task or kill the task is when possibly that it's taking up a lot of resources in our RAM or from our processor. So what you can do is you can specify to kill a task for a certain user, right? Or in different areas. So you can do a task kill. Next. I remember it from, but you can also do a task list to really looking at your task manager, which can be also found in, you know, by doing Control-Alt-Delete or even in using your Windows. So if you right click the Windows button, you can also find all the console that you need. So there's your task manager. This is the graphical user interface, but everything that you can do on GUI, you can also do on command line. Okay. So we have management console that's enabled, Internet Explorer that's open. These are the existing tasks. And then within each task, you would have processes. So notice that there's RDP right here, right? And that's a remote desktop protocol that's only used for Windows environment to have remote desktop access or control. So now you can use RDP in Linux or Apple system. You just have to install it. This is native to Windows. Okay. Question. So when you come across malware, and if it's taking up a lot of resources, or in the case where it's, you know, spyware, when it's reaching out to different sites and things, trying to, you know, connect, and it's not connecting, it could take up your resources. You can go in and end the task, terminate the task, or manage your task. Okay. Yeah, so here they show you how you can look at your RDP, your remote desktop. And then the last part is just the lab assessment. So do your best in answering the question, click submit for each one, and then click done when you're done. Okay. So that gives you a little bit of preview on what would be in the lab. It's pretty simple. I wish that you can, you know, make cables and have great fun with me today, but because we're doing virtually, you're not able to do that, or at least until they get us all the equipment that you can check out. So hopefully they read my resource requests and get things through the channel and get things shipped, but it does take a little bit of time. Okay. So once we talk about protocol, then I'll introduce you to some network sniffer, and or we call it network monitoring tool. So you can see how packets are passed across. But if you're curious, you can use Wireshark or other network sniffer to look at how packets are passed. It's a lot of details, especially if you're using at home. You're going to see all the traffic for everybody. Okay, so a tool that you can go to look at that, if you don't know, you can look for Wireshark. It's a very user-friendly tool. But this is open source. Okay, and there is tutorial on it. There's great training on it. They do certify for their own software now. Okay, there are other monitoring tools. So there's also OmniPeak, but this one I think you can get the free trial. It used to be free. Okay, there is also, so you can see a lot of different ones up here. Aircraft NG, we often use this as with Kali, or we would use this to sniff out wireless. And then this air snort been around since the 80s. You can also use this to monitor or sniff out networks. Okay. And then, you know, there are tools that we use specifically for network forensic, and then there are tools that we simply use just for monitoring networks. Question? Okay, so when you're done with the lab, just shut down the virtual machine, You can shut it down in here, right? You can power it down, or you can go in and turn it off in the panel of your instructions. So this simply just disconnects it. They don't really power it down, they disconnect it. So once I'm done with that, I can close it. Okay, and then you can go in here. So we would power it off. And if you want, you can power the other one off. Okay. This allows it to free up resources for other students, because sometimes if you just leave it on, it sees it as a user in that instance. Okay, any question? Okay, so I'm gonna give you time to work on the lab and the quiz. There is no hands-on project this week, but if you didn't finish it last week, make sure you do so. Okay, get all the assignments to me. Okay. Anything that you missed or you have questions on? Okay, so I'm gonna not require you to be on Zoom. If you have questions, you can stay on for a little bit. And then if you don't, you can sign off and work on your assignments. And I will see you here next Saturday. We talk about wireless. Okay? Any question? Yeah, you can type in your name in the chat. Thank you, interpreter.
You're welcome. The other one, the internet dropped, but I was here. That's why we always have 2 interpreters.
Okay, yeah, it's fine. I understand. Thank you. Thank you so much. See y'all next week.
Have a nice weekend, Professor.
Thank you, you too.
Professor Wynn.
Yes.
So remember I was having that trouble with that 70-inch screen TV that I told you just blanked out on me. So I changed up the T-Con board and it was not that. So I put in a brand new, what I thought was, like I said, the issue was a T-Con board, but once I put in the new T-Con board, I still didn't have a picture. So that's when I ended up getting a multimeter, and I decided to check out the power board. So I checked
A supply, yeah.
Right. So I checked that out, you know, bit by bit, diode by diode. It seemed like it was actually working correctly. So I was able to deduce that as a possible issue. Which was nice because a new power board was like $280, which is like,
Yes.
oh man, I do not
Yeah.
want that.
Yeah, that's good.
Yeah, so I was able to do that was functioning properly, and so the only other boards left was like the LED control board and the main logic board. And it seemed that since it wasn't a backlight issue at all, like not even the flashlight test would work with the LED or the back screen, I decided to give it a shot for the main board. And so I got the new board today just before class actually, and I installed it, and I got it to work. So
good.
yeah, what was originally an $1,800 TV was fixed for $80.
That's great. That
was-
I'm so happy to hear that.
Yeah, it was really exciting.
Yeah, I think I would go to the power board first because that tends to be the main issue with a lot of these screens. Also, a lot of the time on the larger TV, for some reason when they built them, they tend to have a lot of the power distribution issues. But yeah, so you can start narrowing down and troubleshoot. Did you make a YouTube tutorial?
No, I did not. I was just trying to get that TV back quickly because we swapped out, you know, the 70-inch for a 32-inch, and I'm like, I can't take this anymore.
Right, and you know, football season and other things are
Yeah,
finals
my kids,
for the NBA. Yeah,
my kids just needed to watch their shows and stuff too.
That's good. Then instead of, buying another TV for so much more, you can troubleshoot each board. That's fantastic. I'm so happy to hear that. Good.
Yeah, it was really satisfying.
Sorry.
And
Yeah.
what was I going to say? Yeah, I actually noticed that but it seemed like the power board, I mean, I'm sure they're all built about the same, but I'm more used to working with computers, like even as a kid. So I found it kind of really interesting how bare bones it is compared to like a power supply, and
Right.
like wondering how many regulators are even in there, like if at all.
Yeah. Yeah, I think when it's internal components like that, and you would see that when you start opening up, and even with the power supply, when you open up more of the advanced power supply, you would see, it's pretty bare. The reason why that they have the housing and a lot of the components for safety for the consumer, but a TV, not a lot of people are going to open that up, right? Most of the time they just dispose the TV, or if it gets to the recycling plant when they would actually professionally take that apart. But yeah, so you would see that, and you can also see that when you open up smart devices and like tablet and phones and such, it's pretty bare bone outside of the cover.
Yeah, it was surprising. And actually I think because this one's a smart TV, so it had like a little Wi-Fi card in there. It looked just like a laptop Wi-Fi card, like
oh yeah,
regular
same
one.
component.
Yep.
Same, and they buy it from the same manufacturer that Dell and all the other people buy it from. So on the larger IoTs, you're gonna see the same adapter, because and then that comes back to most company that's manufacture stuff in China.
Yeah, it was Foxconn, a lot of the components.
Oh yeah. So you see that, and then if you really want to dig deep, right? Because in security, a lot of time I have my students look up what kind of physical address that's given to certain manufacturers. There's database that you can find that information, because it's governed by internationally. So they're given a range of addresses, and you can see, like, you can even find your own there.
Yeah, it seemed like that everything was actually traceable. I was able to like search for parts by serial, which, I guess the bad news was I saw that a lot of these parts are available. I'm like, oh my God, this was supposed to be the best rated TV of that year in 2015.
Yeah.
And I was like, oh man, there's so many parts. There must be a lot of failures.
But so, like I said, I think that, there are people somewhere in the world that can benefit from, even if you don't put together a video. I think if you put together a simple instruction, like what to look at, doesn't have to be in detail step by step, but if you share that even on a GitHub thing, people can use that to really maximize.
Those WikiHows or something like that.
Oh
Because it was
yeah.
actually I had to piece together a lot of information to get to that point,
Mm-hmm.
So yeah, I could see the value in that.
Yeah. So if you so I think you should share it and even take pictures of it, like even the box for the part, and that way it would have a serial number or something like that, so that way people would know where to look or what to do. I think that would be
Probably the next side gig for sure, I think.
Well, you got bitten by a bug already, so
yeah.
now you're gonna start telling people, hey, don't throw away your TV. I can, and then you can give each one of your kids a TV, or a person in your house a TV.
Bring back some people's their disposed of TV, bring it back from the dead.
Basically, that's what refurb means, right?
Yeah, basically.
And then you can sell it on eBay, or whatever site that you would use. I think and it challenges you to work with different models, and that's how, if you bring it into a television place, they would, at least if they want to do it, because sometimes the parts are hard to get, they won't do it.
That's what I was thinking of how much somebody else might have charged for this. I could have seen it easily.
At least $100 an hour to $150 an hour.
Yeah, big time.
That's the rate would go for. And even on the cheaper side, like if you see like a little hole in the wall, or if they're working at a home, or in the corner of the mall, like if you go to, because I see it I live in Moreno Valley, so there's a swap meet right off of Sunday Meet in Paris.
Oh yeah, the Rio.
Yeah. So they have like a computer repair, TV repair place in the corner I went, oh, it was there like a year or two ago. I don't know if it still exists, but you see they charge, like I looked at their rate, 70 and up, 60 and up on certain things. The easy stuff is 60. So even on like little places like that, they charge a lot. What you can do, if you make this a regular thing, you should, I tell my student, you don't have to pay for an overhead like that. Get a decal sticker, right, that for your car, and then just put it on your car or wherever you go. Just have them message you, right?
Oh, right. Yeah, I've seen those. Yeah.
And then that way, you know, you can come and pick up the device, or they can drop it off for you. And then you, once you repair it, then you can just, you know, just return it back, and then they'll pay you. So, and you can use all digital payment for that to be able to keep log of it, and so for tax reasons. So you can definitely do stuff out of your home without paying a lot. But yeah, put a decal sticker on your car and then be able to make a business out of it. But I think if you can get good at this, you can make a lot of money. A lot of people, you know, they buy TVs and then, you know, it goes bad. My Vizio, I only got it for a few months, and I start noticing there's power supply issue
Yeah, it was the
already.
Vizio. I had it for
Oh yeah.
5 years. It was rated the best of 2015 by CNET. And
Oh, okay.
I was like, okay, well, so it should be okay. Plus, I got it at Costco, so I'm like, okay, if anything ever goes wrong, I can easily return it. Yeah, I was really taken aback. I have like a TV that's older, 46-inch, which hasn't had any problems. It's like an old Apex, is what it was. And I was really surprised that the Vizio did what it did.
Yeah, I read online that they have a lot of issues with, for some reason, they have a lot of issue with their power board, because, you know, there were some models of Sony that had the issue, but Sony corrected it. But I think that this is how they can cut the cost for the Vizio. Number one, it's assembled in California, in Southern California. They're not that far from here. So you get, for Californians, that's why you see a lot of Vizio being sold here for very cheap. Number two, you know, they cut some of the costs, where if you compare that, Samsung had reduced their costs, and you see the grade in their TV has gone down, because, you know, they just produce things at a cheaper rate, and it doesn't last. So right now, your television, if you're lucky, it will go past 5 years. Yeah, I had an older one that I finally replaced after like 12 years. So I had an LCD.
Right. Well, yeah, see, and then
Yeah.
for me, it was just like, because just the way our living room's set up, the 70-inch is optimal for how far the couch is away from it.
Hmm.
So it's not just, I mean, I like a big TV, yeah, but it's also just what works for the whole room. So yeah, I was like, I'm not going to pay another grand plus for the same size TV. No way. I'd rather get my hands dirty and try and figure it out.
Yeah, good. Now you fix it. So now you should tell all your friends and family members, if their
I
TV
did
break,
actually.
give it to you. Yeah, and
Yeah.
then, because most likely people will buy another TV, and then you can have alternate backup TV. All the smart devices now, it's great in that once you understand how computing works, it's pretty straightforward, or electronics actually. So good. Yeah, I'm
So
so
that's
happy you
the
did.
update.
Yeah. Well,
Well,
good
thank
for
you.
you. Yeah. So take pictures, share tutorial. Okay.
We'll do. Thank you.
All
Have a
right.
good
Have a
weekend.
wonderful weekend.
You too.
Bye.
Bye.